Guys, today is a huge day for people using OpenAI and LLMs and GPT-4. OpenAI has released fine-tuning for the GPT-4o model as well as the mini. So today I want to walk through a guide on what this means, how do we do it, why do we want to do it, everything surrounding this use case, and show you a couple examples of how we want to do this in the platform, what the documentation looks like, and everything like that. So, kind of out of the gate, why do we fine tune? If you're getting pretty good results with ChatGPT or just GPT-4 by itself with a static or maybe even a few shot prompt, why do you want to do this? And the simple answer is fine tuning models, making them specific to your use case, guiding them towards your specific tone, output, style, everything like that improves accuracy. You can go through any research paper, honestly, nowadays that compares, results from larger LLMs to different models and things like that. And you will commonly see that fine-tuned models, even when they're smaller than ChatGPT, even when they're smaller than these LLMs, outperform them. Now, why is that? The reason really being that we are guiding this model towards our specific use case. We're allowing it to become much more domain and task specific. And this shows up in pretty much everything you see on the research and use case side. Products that are in production using AI are using fine-tuned models. Out of the gate, when they don't have a lot of data, maybe they are using just the ChatGPT or the OpenAI with prompting and things like that. But everyone is moving that towards fine-tuned when they have enough examples and enough data to be able to do that. I went through a bunch of the research papers that we have saved in our repository. All of them show the same thing. Here's a great example of one that I pulled up from a talk I just gave. These are data sets that focus on some disease classification and some of the things like that, some NER, named entity recognition. And you can see the fine-tuned on the data sets all outperform ChatGPT for this specific use case. Now, this is fairly common in medical, which is what this is, where ChatGPT is just not very good at medical use cases, but the results are staggering. I mean, you can see we're talking about huge increases when you look at the BERT, Roberta, and BioBERT. These are models that are tiny compared to ChatGPT, and they're all killing it in terms of accuracy. Why? Because they're fine-tuned on this data. They are specific to this data. They are better than some sort of general model like ChatGPT that is usually pretty good at everything, but not insanely good at one specific thing. Here's another one. This came directly from OpenAI. You can see that on these specific benchmarks, the SWE, the BERT, these are some very popular domain-specific benchmarks. Fine-tuning ChatGPT-4o outperforms base GPT-4o. It outperforms ChatGPT. It outperforms everything. They are reaching state-of-the-art accuracies with these. And what is nice about the way that OpenAI sort of introduces fine-tuning is that it's very easy for us to integrate into our current GPT-4 implementations. It's a simple line change in the code, pointing it to a fine-tuned model versus sort of the generic we have there. Now, maybe you need to make some prompting updates and things like that. But at the end of the day, even OpenAI will show you that fine-tuning this model, and really fine-tuning any large language model or any model for that case, outperforms what you have at a baseline level. So wanted to break down sort of the pricing. One of the things that people look at when they look at fine-tuning is, what does this do to my cost? They usually have a very good understanding of the sort of structure of their cost if they're using an open source model, or if they're using just GPT-4o and they're paying by the token or something like that. And this is always a concern because fine-tuned models through OpenAI are generally more expensive for those that are around since, even the GPT-3 days. If you remember what the cost structure looked like for GPT-3, fine-tuned was insanely expensive compared to the base models. And, that's just something you'll want to understand as you move these to production. Now, OpenAI has said, and you can clearly see that the cost of using their models and services has just I can't even stress how much it has gone down. It has gone down 99.99, something like that over time. I think off the top of my head, fine-tuned GPT-3 Da Vinci was $1.20 per 1,000 tokens. I might have that wrong, but I think I'm right about that. It was either, yeah, I think it was $1. I think it was 12 cents with the base model per 1,000 tokens, and it was $1.20 per 1,000 tokens with a fine-tuned model. And as you can see on these costs for using the fine-tuned one, we are talking about entirely different universes. So GPT-4o, which is the faster version of GPT-4, it's more affordable. $25 per million tokens of fine-tuning. That is a lot. I mentioned there, a token is roughly 3/4 of a word. The math breaks down a little bit different, but over a large sample size, it's roughly about 3/4 of a word. $25 for a million tokens in fine-tuning. And then the inference on the input, so the tokens you are providing as the input as a part of your prompt, is $3.75 per million. And then inference is $15 per million tokens on the output. GPT-4o mini, which is a faster, more affordable version of GPT-4o, is insanely cheap compared to that. Look at the cost comparison between these. $3 per million tokens for fine-tuning, 30 cents per million tokens on the input, and $1.20 per million tokens on the output. And I mentioned there because you might say, well, it's smaller, it's more affordable, it's going to be worse. GPT-4o mini surpasses 3.5 turbo, which is a lot of what people were using in more of these cost centered environments. If you have a use case that just runs a lot of data or generates a lot of tokens or anything like that, a lot of people are using 3.5 turbo. GPT-4o mini is better than 3.5 on most of the relevant use cases that we see. They have more information in their blog posts about it, but on sort of the key benchmarks of how good is a language model at general tasks, GPT-4o, is already better than 3.5 turbo out of the box. Imagine what it looks like when you fine tune it. So one of the reasons I wanted to make this quickly is you should be doing this now. If you have a use case using GPT and you have a data set behind it, maybe you're doing dynamic prompts or few shot prompting or anything like that, and you have a large data set, you should be doing this fine tuning now. OpenAI is offering free fine tuning for this. You can see, a million training tokens per day on 4o, and mini, they're offering 2 million a day for what is this, about the next month or so? Yeah, about the next month. From the time of me recording this, you should be doing this now. I mean, it's literally free to take your model from a generalized, overly optimized model to something, if you have the data set, that is going to be infinitely better. So I strongly recommend this. I want to take a look at the docs and kind of walk you guys through what this looks like so you can get going with this immediate. And OpenAI does make it fairly easy, but I do kind of walk through some of my thoughts around what actually goes on when you do this from experience versus what they say goes on. So let's take a look at that. So this is the documentation page for fine tuning on OpenAI. I'm going to try to walk through this here, give my thoughts, take a look at some things. They mentioned fine tuning lets you get more out of the models by providing higher quality results in prompting. Of course, I mean, the goal of prompting and using few shot examples and things like that is to guide the model towards your specific use case or your task or your specific output style and things like that. And as you can imagine, fine tuning that turns those knobs more than, say, the 5 examples or so you can fit in a prompt of how to complete your task. That's very straightforward. The token savings, I would be interested to see what the math looks like on that, because you're now paying more to use the model, but in theory, you should need smaller prompts. If you have enough data, you might not even need a prompt at all. You definitely don't need few shot examples and things like that. So the reduction in prompt size versus the increase in cost is kind of an interesting calculation. I'd love to see what that looks like. And it's something you should look at when you go through this. I'd recommend fine-tuning a model for free right now, and then sort of doing some sort of cost analysis of what that looks like, because your tokens on your input should be greatly reduced compared to what you currently have. And then, kind of seeing what that looks like from there. They mentioned fine-tune a vast amount of text. Yeah, they mentioned to use models effectively, we include instructions, sometimes even examples in the prompt. Demonstrations how to perform the task. That's what I just mentioned, few shot examples. Fine-tuning can fit the prompt, letting you achieve better results on a wide number of tasks. Once a model is fine-tuned, you don't need to provide as many examples in the prompt. This is correct. If you have a use case where you're using like 10 examples, 8 examples, you might not, it depends on how large your fine-tuning set is, but you still might even want to include an example or 2 examples or something like that in your prompt. It's a little bit on a per use or per use case basis, but the general idea is that, of course, you will need less examples in your prompt for this. You also probably need, if you have an incredibly complex prompt where you've outlined like a bunch of rules and like framework stuff to like fit specific outputs and schemas, which, when you get in the weeds of like really complex use cases, you kind of need, because you fine-tuned on those rules and you fine-tuned on those specific output schemas and things like that, you shouldn't need that anymore, which is kind of nice. Cost savings, lower latency requests, fine-tuning involves, so these are kind of the steps at a high level. Prepare and upload your training data. Train your model. It's not that straightforward, but it is fairly straightforward. Evaluate your results and go back to step 1 if needed. That's general data science evaluation, things like that, and then use your fine-tuned model from there. So this is the list of models that can currently be fine-tuned. As I mentioned, they just added these two to the list, GPT-4o. You could fine-tune more models before, you still can, but these are the 2 that are brand new and are available for you to use right now. We expect GPT-4o mini to be the right model for most users. Yeah, I would generally agree with that. I think if you're fine-tuning a model, you now, for a lot of use cases, don't need the other ones as much. Once again, you should be in a production setting split testing this across maybe different models or different training strategies or different things like that. But that's a decent general guideline that I'm sure is fine for most people's use cases. When to use fine-tuning, better specific applications, but requires a careful investment of time and effort. It's fine. We recommend first attempting to get good results with prompt engineering, prompt chaining. Key reasons. That is actually pretty good advice. Yeah, that's good results is kind of relative. I don't really love that they didn't specify, but it is a little bit hard across everyone's use case to specify. I would make sure that your use case is feasible through prompting. Like, you don't need to take it to 90% accuracy or something like that through just specifically prompt engineering and things like that if you're going to be fine-tuning. But you want to make sure that your use case and your framework for what you're doing does make sense in a sort of prompt style approach where you are providing tokens in an input and then you're getting tokens generated in a text format on the way out. This doesn't change the type of use cases you can do with OpenAI. It just makes the current ones better. So that's an interesting note that they put. Let's see what the reasons are. Many tasks which our models may not initially perform well, but the results fine-tune may not be necessary. There's going to be a trade-off there where it reaches a point where you're spending so much time prompt engineering to try to get small gains in accuracy to where like fine-tuning makes sense. So like what you'll see with most use cases is it's like really quick to get to like 70% accuracy. And then as you go up, the amount of effort and time required through just prompting goes up. So like the going from like 90 to like 91 or like 92% accuracy is going to take way more time than 70 to 72, if that makes sense. Because you essentially are reaching the limits of what a prompt plus static examples plus rules can achieve. You're just reaching a barrier at the end of the day. Like you were just reaching sort of the top of the limit there. But I think that if your use case is, hey, we want to get to that uber high accuracy, fine tuning at some point is just going to be a better return for your time and money than just trying to exhaust all routes through prompt engineering, in my experience. Iterating over prompts and tactics has a much faster feedback loop than iterating with fine tuning. That is true. It is much quicker from a time perspective to evaluate the results from your prompts and like iterate on the feedback with just use cases than it is fine tuning. But it's much more manual. Like the feedback loop when iterating prompts is a much more manual and so like human time is just more than fine tuning, which is going to be a lot of kicking off a job, choosing your parameters, getting results, and essentially just looking at them and deciding what options to make next. Like it is because fine tuning takes a bunch of time. Like I'm sure it takes more like time, but not like actual manual hours going into that. So that is true. I always recommend sort of, starting with prompting, taking it to kind of the limits, and then you're going to be able to sit there and go, I can't take this any further by just optimizing my prompt. Let me just fine tune and go from there. And if you have taken it that far manually, then you're going to see really good results, assuming you have a quality data set to fine tune with. In cases where fine tuning is still necessary, initial prompt engineering work is not wasted. We typically see the best results when using a good prompt to fine tune. Yes. That is true. I wish they would have mentioned that the more you fine tune, the more data that you have to fine tune, the less relevant the prompt engineering work is when talking about fine tuning. So like when you are fine tuning, we'll see it below. It's the same exact structure as when you're using a prompt in the platform or something like that. It's the same sort of system prompt, user prompt, and then you get an output, which is the assistant. The more examples you have, the less relevant the system and user prompt are going to be, because the model is fine-tuning on the relationship between those, and it's learning it through a training perspective instead of a human feedback loop evaluation, if that makes sense. So I wish they would have mentioned that while it's not wasted, if you have a ton of data, then it's just not going to be as necessary. A good example would be like, let's say you're doing like a document extraction tool. So like you upload the text from a PDF, and then the output is like named entities or something like that. If you have 10 examples to fine tune on, the prompting work you'll need for the model to understand your use case, your goal state output, how to go through the documents is going to be more than if you say have 1,000 examples of how to complete that task and just say, I don't need as much prompting. I can just learn the relationship between these outputs and these inputs. So I wish they would have mentioned that, because that is, as your data set grows, like you are just not going to need as much of that prompt engineering work, but it doesn't hurt. And it's like they mentioned, it's not wasted. It's not going to negate, especially when we're talking about like super large data sets. Common use cases where fine-tuning can improve results. Yeah, so setting a style, a tone, a format, a schema, something like that, like I mentioned, really great for fine-tuning, because that is often prompted with just a couple few shot examples or like a rules section in the prompt or something like that. And fine-tuning can just learn that relationship between what you want to do in the input versus what that specific schema or style or something like that looks like in the output. Proving reliability, producing desired output. That's that goal state output that I mentioned. Models getting better at understanding your specific use case and what needs to go into what you are looking for with that output, not what the model thinks, not what an engineer thinks, not what a user thinks, what you, being that stakeholder with this model, believes is the desired or goal state output, as we put it. Correcting failures to follow complex prompts. That's essentially the above. Edge cases, I shouldn't need to, if you're familiar with fine tuning in any domain or any world, that's one of the best places that edge cases get a little bit better. That is where having a solid prompting structure in your data set helps as well, because even, if you just don't have a lot of examples to fine tune on, those edge cases could still struggle because they're just not highly correlated enough in your data set. There's just not enough examples of how to complete those edge cases in your data set. And the strong prompting can help with that as well. This is an interesting one. Performing a new skill or task that's hard to articulate in a prompt. It goes back to, the goal here with fine tuning is to understand the relationship between that input and that output. And, when we think about what leads to a use case that's hard to articulate in a prompt, it's generally going to be around things that are style specific or rules that are complex or stuff like that, where just fine tuning and just sort of brute forcing that relationship between the two is going to be much easier. Think about these cases when it's easier to show, not tell. I don't know what that means. Explore. More expensive models. Yeah, I mean, this is the other one that we saw before, where if you saw that in that example from the research paper, the fine-tuned tiny model compared to the big Goliath ChatGPT, not only achieved the same, but outperformed it. So now you can use smaller, less expensive models and be able to go from there. I mean, really, like when you think about the type of customer or somebody like that uses an open source LLM that's smaller than ChatGPT or something like that, a lot of it is cost driven, with the idea that, hey, I think I can fine tune, I can commit the time and resources and cost to the fine tuning of this smaller model to perform at the same level or outperform ChatGPT, which in the long run, in terms of inference cost, is going to be more expensive. So we're going to front load our effort and our cost into fine tuning this smaller model, with the idea that because it's smaller, it might be cheaper to deploy, or you won't have inference cost or things like that. And then in the long run, it will be more controllable and really less expensive. This is a good example here, where if you have a use case on GPT-4o, and then you could fine tune GPT-4o mini on that specific data set, you could probably outperform the base GPT-4o. And it would be more cost effective, which is kind of interesting. So for the data set is essentially the same as the way that OpenAI has done fine tuning for the other models. Nothing is really different, other than if you're using a model that is prompt and completion versus messages. That's the only difference, and you can see that here. So here's an example of a data set where we would have examples of our system prompt. Right here, we have our user. So like, what was the actual instruction or what was the input? And then the assistant is the output. This is just like how you use it in the playground. This is the same exact workflow. And then the model learns the relationship between the system prompt, the user, and then those two relative to the completion prompt. The assistant prompt. That's sort of our output that we get there, just like we use the playground. If you're using some of the other models, like Babbage and DaVinci, which are completion models, so they're not they're not the user system assistant. It's just a input text and then generated text. This hasn't this hasn't ever changed. This is just your prompt, which is your input text. So it's going to be your system and your user stuff, and then the completion. This above one, this is going to be the GPT-4o and GPT-4o mini. This is just showing a use case from an older model. An interesting one is, what do we want to do when we have like a chatbot use case or something where there's multiple steps? So it's not just a single system, user, and then assistant. Like the example is a conversation, which of course has multiple steps. And you might even see this in other use cases, like if you're doing the document processing one, maybe you are extracting, I don't know, you're extracting like a summary, and then you like generate, or you, how about this? So you have your input document, you have your instructions to extract named entities, you extract those named entities, and then you want to take all of that, including your now newly generated named entities, and you want to generate like a summary or something like that. So this would be like another, like, where we have like multiple steps that go into it. Very similar here to kind of what we have, where you just sort of, just like you see in the playground, you just go through those same steps. So you have your system, you have a user, this is going to be your instructions, you get an output, and then let's say the next step is another input, another user defined input, and then another output. So it kind of lets you do that multiple steps, like you would see in the prompt, and make sure that you train this as a full conversation log instead of little chunks that don't have the context of the full conversation. That's where this is really important. Like you could take this row and you could split it into system, user, assistant, and then the next one is that same system, the new user, and the new assistant, but you wouldn't have the full context of the conversation, which led to that second set of generated user and completions, if that makes sense. Default behavior during fine-tuning is a train on all assistant messages with a single example. To skip fine-tuning on a specific assistant message, a wait key can be added to disable fine-tuning on that message, allowing you to control which assistant messages are learned. The allowed values for wait are currently, that's kind of interesting. I don't really know why. Yeah, it's kind of an interesting example they used here for this, where I guess it's like an example where you want this user input, what is the capital of France, not to tie to the first output, but tie, oh, I see. Oh, okay. No, this is kind of interesting. So you really wanted to learn this full relationship, but for this specific example, only this output is relevant to the original user question, which was, what is Paris? But you need to have those other conversation steps in there to show that those were all inputs to reach that level. So like when you have a multiple step conversation in the platform, or the playground, or even with the API, everything that's been generated above correlates to that output. So like the only reason OpenAI knew that this is how we should generate this sequence, the only way it knows that this is a sequence we could generate is because it can see all these steps that are above that include, of course, the first question. And so you can essentially say, use this assistant line as more of a piece of information than an actual fine-tuning point. That's kind of interesting. I would recommend chopping this up a little bit different. So like you could have one row that, fine tunes on that whole conversation, and, your end output is this one. And essentially everything above, including the previous assistant generations, is included as knowledge to reach that point. Also chop that down and create another row where the model learns just that first half. So like just this, because that's still a relationship, depending on this use case, that you want to learn, that like, hey, when I provide this system and I provide this original question, you generate this answer. But then it also learns that when you ask sort of follow-ups and things like that, how to follow that specific style and tone. I would split these into two, one being the full conversation with that final completion being that weighted as a 1, saying like, hey, this is the output we care about based on all this above. And then I would have another one, which is just that first one, so that we can learn that relationship as well. But that is kind of a nice feature. I'm glad they showed that, because I think that would have been a little bit confusing, knowing that like you aren't training on the assistant messages above, because that's not the end state there that you want. It's that final one. Prompt information generally recommends, yeah, we already kind of saw this above. Best and most general results, especially of relatively few, 100 training examples. It may take more training examples to arrive at a good result as the models learn. Yeah, I'm not going to comment on that because I want to talk about that down here. To fine-tune a model, you're required to provide at least 10 examples. We typically see clear improvements for fine-tuning on 50 to 100 training examples, but the right number varies greatly based on the exact use case. People ask me this question all the time when we, like when a customer says like, how much data do I need? They want to know how many examples is right for the use case. And I tell them every time, I don't have a clue. Until we do that first training and iteration round and get like a baseline accuracy, I don't know. Everyone's use case is different. I can give you suggestions based on, similar use cases I've seen in the past. But if it's very unique or it's different, there really is no telling. I mean, they kind of said this as well, where it's like, hey, we've seen improvements, whatever that means, from 50 to 100 training examples, but the right number varies greatly on the exact use case. I agree with this 100%. I even think 50 to 100 is super light. I would almost never recommend somebody use only 50 to 100. 100 would be like the minimum, and the use case would have to be super simple, like text classification or something like that. Most of our fine tunings and things like that, way more than 50 to 100. I'm surprised they even put that in there, to be honest. But they said like the right number greatly varies based on the use case. There's no way to know until you kind of do that iteration, get a baseline, and then you can figure out from there, hey, we're right here. How do we get to here? We know how much data we used here. We know what our prompt looked like. We know what our sample diversity looked like, everything like that. How do we actually get to here? Recommend starting with 50 well-crafted demonstrations, seeing if the model shows sign of improvement after fine-tuning. That is correct. Some use cases may be sufficient, but even if the model is yet quality, improvement is a good sign. All of this is correct. All of that is 100% correct. I couldn't have said that much better. Your data set, when you fine-tune, and this is the same as few-shot examples, this idea, needs to be correct. We call it like a golden set, because the model is going to learn a clear relationship between the data that is provided. So like whatever the input is, whatever your output is, it needs to be correct. It can't be kind of correct. It can't be incorrect. It can't be, well, it's correct if it's something like this. Like it needs to be 100% correct. I cannot stress that enough. I would rather you had, like they mentioned, 50 to 100 known, well-crafted, correct examples than a data set of 100,000 that's like, these are pretty good, but some of them are wrong. Like that is such a nightmare scenario, because you are going to run into this weird case where the correct data turns the knobs in the right direction and the wrong data can turn them back a bit, because it just doesn't make sense. It doesn't follow the same learned relationship that we see in the correct examples. And so it can lead to some weird things like that are really hard to understand why it's wrong. It's really hard to kind of see if you know that some of the data in there is wrong, but you don't really know maybe exactly what it is or stuff like that, it's impossible to tell what the model figured out and what it didn't, other than just looking at an accuracy score and saying, this is where it is, hope that's right. It's just very hard to do that. I would much rather start, small, well-crafted, like they mentioned, get that baseline, and then we can figure out what we need to do from there. But there's no improvement suggests that you may need to rethink how to set up the task. They say, or restructure the data. I would say that as like, hey, your data set sucks. Like something is wrong here in either the way you're constructing it, or it's just incorrect. Whatever your input is and the output that you expect in your data set, that relationship is wrong. And you see this commonly with data that is, web scraped, or, oh, I don't know where we got this. Somebody built this. Like, you see that, and it's going to cause you issues, and you're going to run into problems. I'm actually very glad that they put this in here, because everyone's going to come to this and say, how much data do I need? And it's very hard to know what that exact number is before you actually do an iteration, and people are going to fine tune a lot of junk. So this is really nice that they put that here. We recommend splitting into training tasks when submitting a fine-tune job with both training tests. We'll provide statistics on both during the course of training. Yep. These statistics will be your initial sign of how much the model's improving. Additionally, test that early on. All that is correct. All that looks really good. They put some token limits. Huge stuff. I don't know what else to say there. The inference size for these models is, if you're somebody that's doing this with GPT-2 and GPT-3 back in the day, this is a ridiculous number compared to that. So very nice, very, very cool to see what we see there. Examples longer will be truncated, the maximum length of the tokens. Yeah, it's fine. They put estimating costs. I showed you the thing before. This is fairly straightforward. I don't even know if we really need that. Once you've compiled a data set, before you, it's important to check the data formatting. Do this. We create a simple Python script. We find errors, review. This is actually very nice that they have this. It's very useful if you have a super large data set that's hard to visualize. It is nice that you can plug this into a script and go from there. I also have a script for converting common data formats like pandas and things like that into the correct format that's needed for this. I will provide a link to it in the description, but I do have that as well if you have a data type that isn't they use JSON long, so a .jsonl file. So if you have like a CSV or like a text file or like a pandas data frame or something like that, I do have a script that you can use. Put it down below. It's very helpful. So you can upload the training file just like that. They do also have a very nice dashboard that makes this easy to use as well. You essentially hit create. You can drag and drop. You can provide a validation. You can provide some things like suffix so that you know what it's called, and a random seed and things like that. They do. This is where I cringe a little bit, knowing that this is, and I think honestly any like ML, scientist who does a lot of fine tunings kind of looks at this as like, this is just rough. These are the hyperparameters that need to be optimized and iterated on like over a sequence, multiple trainings, multiple steps, things like that. It's hard to do in like something like, generalized fine tuning tools for like anyone's use case are a little hard to build, because OpenAI doesn't know what your exact batch size should be. OpenAI doesn't know what your learning rate should be. It doesn't know how many epochs you should use. They make an auto suggestion and then just kind of go from there. I think the best advice I could give to somebody who's doing this as like a novice is use the autos and then read about optimizing these parameters and then make iterations from there. That's probably the best advice I could give, because this is a much more complex operation than OpenAI makes it seem. In my opinion, I mean, anyone that's done model fine tunings knows, like, it is not this straightforward. There's going to be a lot of testing of different variations of these hyperparameters to try to reach whatever the best loss is or something like that, or error rate, based on whatever you're doing. So I don't know. I would read about using these. Yeah, they give like some suggestions, but I would do more reading about this. If you want to read about like hyperparameter optimization algorithms and things like that, that essentially go through a space, a gradient space, and then try to optimize these variables for the best accuracy or whatever the goal state number is. But that's probably where I'll leave this. I would recommend starting with auto, letting it run, and then learn about how you're supposed to optimize these for your use case based on the results you get over time. This is probably where you're going to spend a lot of your time, is optimizing these three variables to get the best result. Honestly, this is going to be the one you spend the most time on. Oh, sorry. The learning rate is going to be the one you spend the most time on. So, I would recommend, learning about that, getting used to it, and trying to figure it out from there. Create a fine-tune model. We just saw that. You can do it over here in the UI as well. They mentioned the API and show you some examples of it. Using a fine-tune model, what's very nice, as I mentioned before, is it's really just a one-line change. So like, here's a very basic call to GPT-4o. You would see this with any piece of code that's making this call. This is the only line you have to change, is just this model one. So instead of calling GPT-4o, you are calling your specific fine-tuning, your fine-tuned model, and going from there. So that's one of the nicest parts about this, is the code changes that are required at a base level are very straightforward. It's very nice. Checkpoints. This is something that you will get used to as well, when especially using a tool like this, where the fine-tuning process is generalized so that anybody can do it. Using a checkpointed model is going to be very useful, so you can sort of just have a version of your model before something fucks up. So like, over time, through the training process, you will see the accuracy, or more importantly, the loss kind of, go up and down and kind of shift, and then it'll eventually reach some sort of point where, you've kind of reached the capacity of your training job on that loss rate, and then go from there. But you might overfit your model, especially if your variables, your hyperparameters aren't perfect. You're going to overfit that model. So you can use a checkpoint of some set of weights where you didn't overfit, and then you can either start from there or just use that model or something like that. This is all very basic for people that have fine-tuned other models and things like that. But it is nice that they have sort of built-in checkpointing so that you can make this a little bit easier. Yeah, so you'll see here we have your how OpenAI believes you should be sort of evaluating your models. You have your loss, and then you have a token accuracy. Yeah, loss is 100% something you should be looking at. That's going to be one of the most straightforward evaluation functions that you can view for this. Now, token accuracy, I'm not the biggest fan of token accuracy, because in a lot of use cases, you can have different tokens at a specific point, but still be correct. Like, your output can still be correct, especially in things that are more relative, like summaries or like blog post generations, or things where like a correct output is kind of relative. If your summary looks different than what the one was in your test set, you're going to get killed on that token accuracy. But you might look at the output and say, this is still correct. Like, the key information was still there. Maybe it just goes in a different order. It's longer, it's shorter. Like, something is different compared to it. So this one, it's very use case specific. Use cases where either there's not a lot of tokens generated, like a classification, or use cases where there's like a very specific output that can exist, like classification, maybe something that uses like a very set schema, like if you're generating like code or like JSON or stuff like that, where like you have to follow some sort of schema for it to be correct at all. That's where I think token accuracy falls into place a little bit more. But use cases that are more sort of relative on the output side of what's correct, I would take this with a grain of salt, in my opinion. It shouldn't be awful. Like your output should not be awful, but I think it should be, take it with a grain of salt. We got some other stuff here. This is just showing you like the output CSV file. Let's see what we have here. Iterating on data quality. So you've done your run, you have sort of your baseline steps. What should we be doing on the data quality side? Fine-tuning job not as good as you expected. I don't know, if you're doing your first run, like a baseline run, I don't really know what you should expect. But this is a little bit more focused on like, what if you're on like multiple iterations later and you're not making improvements, or maybe you're going down in accuracy, which would be a nightmare. Considering the follow steps, collect examples, target remaining issues. Great point. When you look at let's say you have an 87% accurate model and you're looking at the 13% that isn't correct, a lot of that's going to be the fact that they're edge cases. They don't have as many examples in the data set, so it's harder for the model to learn the relationship. Maybe there's just stuff that's wrong in the output. There's just weird use cases. We did one. This is a great example of it. We did one where we were fine-tuning on, we were classifying products. So like e-commerce, retail products and things like that. We were classifying them into categories, and we were looking through the output that was incorrect. And there was like a couple categories that were like always wrong. And the two reasons were, one, those were the categories that had the least amount of data, so the model struggled to learn that relationship. And two, those categories were the ones that had the most data errors. Some of the product data had been web scraped, and so the actual product data that was there that was supposed to match to that category was like filled with like junk. Like it was like unrelated to a product at all. Like something had messed up in the scraping job, and so it was just like random. And so it was like, okay, well, like this makes sense. Like, the model doesn't know what this is at all. The relationship that's built on everything else makes no sense for this. So that's one that you'll see there. Adding more examples, perfectly fine. Directly show the model how to complete these aspects correctly. Yep. Scrutinize your existing examples. This is one I would say for when you have a pretty good accuracy, and now you're trying to figure out how to just eke out those extra percentage points, especially if they fall into the category of like an accurate result. Like if those come back as correct. If you have like in that categorization example, you're like 80, like let's say a specific category is like 85% accurate. You're trying to figure out like that other 15%. Maybe it's just like, in general, the model doesn't have a great understanding of that use case, or at least great to compare to what you want to get it to. And so maybe you have some grammar or like logic issues and stuff like that, things that pre-processing can work out that might give you a good bump, and make more sense than adding more examples, because maybe this is a category you've already added a ton of examples to, and you know that that's probably not the main issue. Schedule this meeting for you. Yeah, there's a great example there. Schedule this meeting for you when it shouldn't. See if the existing examples teach the model. Yeah, cool. So the balance and diversity of data. This is one of the most relevant ones, especially when we talk about like above, where they said, oh, like, what did they have? 50 to 100 examples is fine. If you have like a super diverse sample set relative to the possible outputs, then like, sure. But if your data is like they put 60% of the assistant's responses say I cannot answer this, but at inference time only 5% say that, then you're going to get this is just a great example of it. That was such a good job by them. Your training data should strongly reflect your inference time data of what's actually being done. And so if you don't have a bunch of diversity in your inputs, like if 60% of the assistant responses should actually say, I cannot answer this, then like it's fine. But if the actual usage of the model is more diverse, there's more sample diversity, then this isn't going to work. Same idea with other use cases. If you have like a document extraction use case and all of the examples you gave were medical documents from a specific provider, and then like in the actual usage, that's only like 50% of the documents that come in, and the other 50% are other providers, other documents, things like that, then like your sample diversity in fine tuning does not reflect the actual usage. And so there's some sort of trained relationship that's created, but that relationship doesn't exist in your new data. So that's one, that's a very straightforward one to see. You'll see this often where you'll have like a super high training accuracy, and then you'll like roll it out to production and you'll be like, what the fuck happened? Like now it's like 50%. Normally because your training set doesn't actually represent what's actually being, done to the model or what the model is being used for. Make sure training examples contain all the information needed to respond. That's very straightforward. Look at the agreement consistency in the training. If you aren't getting exactly correct data for your fine-tuning examples, then the model's not going to figure that out. The model just takes whatever you give it and whatever you give the output and say, this is a correct relationship. I don't care who it came from. I don't care what happened. I don't care what we did to get to this point. This is a relationship that is correct. And so, you need to make sure for that. Iterating on data quality, I'm going to skip that. I feel like we've talked about that. Iterating hyperparameters. Interesting. They have a section here for this. Initially training without specifying any of these, allowing a SPIC default for you based on the dataset size. I think that's fine. Was not follow the training data as much as you expect. Increase the number of epochs by 1 or 2. I don't know if I would give this suggestion. There's probably some calculations out there by people like weights and biases that are like really good at this stuff that say like, hey, based on the size of your training data and then the number of tokens, like here's what your epoch count should look like. I bet you there's something out there for that. Just statically saying increasing epochs by 1 or 2. I bet you there's a more efficient way to do that. The model becomes less diverse than expected. Decrease. That's essentially the same thing. Does not appear to be converging. This is probably going to be the one you see the most. Your loss isn't going down enough during training. It's just sitting or something like that, and your learning rate just needs to be increased. The model needs to make bigger jumps in that training process to have the possibility to go down in loss quicker. You're just running the jumps you're making by the learning rate are just not enough based on the data set that you have, essentially. Let's look at a use case. I don't really want to do these two. I think these are very straightforward. Silent tone and output, those are just like generic use cases. I am interested in how fine-tuning adjusts tool calling and function calling, because that's just such a big part of production pipelines nowadays, especially with like agent-related stuff. Let's take a look at this. Chat completions API supports tool calling, including a long list of tools in the completions API. Fine-tuning a model with tool calling examples can allow you to blah, blah, blah. Each line, including a list of messages. Oh, wow. See, this is kind of cool. See, this allows you to fine tune some of the format responses, even when the full tool definition is presented get more accurate. See, this is kind of interesting that you can fine tune understanding the usage of tools. That's, back in the day, you would have had to fine tune back in the day when you had to do like just prompt and completion. If you wanted tools to be used by like other systems, you'd have to fine tune essentially like generating like a token or something. So you would like pick like a tag or like a token that to a code base knows to use like an outside tool. So you would like fine tune the model to understand and generate like dash Wikipedia dash dash or like dash dash Salesforce API dash dash or like something like that. The model would learn that that set of tokens is correlated to whatever the input is, which is normally like, hey, use this tool or something like that. It's nice that you can kind of fine tune the tooling like directly into it. That's very nice. Function calling, this probably looks about the same. Yeah. For although it's different, the idea of how it's used is the same as tools. I don't really need to go over that. That's essentially the same. You can see it's literally the same format, just functions. Weights and biases, don't really want to chat about that. This is not new. This stuff all exists before. Costs. Cool. Very nice. Let's see if there's anything I didn't cover on this that I wanted to. Was there anything over here I didn't cover? No. Base models. Cool. Well, I think that's all I've got. Like I said, I will have a script down below in the description that you can use to take some of your specific data formats like pandas, text files, and CSVs and converts them to this format, as well as allow you to kick off some jobs and do things like that for the fine tuning. All of that will be down below. I hope you found this useful. Wanted to kind of just walk through the new release of this GPT-4o fine tuning for both the mini and the normal. I am definitely looking to hop into this as soon as I can. This is going to be super useful for pipelines that are already using, some sort of static prompt plus few shot examples from a database or something like that. This is going to allow us to clean that up very easily and give customers just an iterative workflow that can be improved over time through simple fine tuning with, quite honestly, a very nice, easy to use dashboard. So hope you enjoyed that. Subscribe, check it out, join the Discord, everything like that. We'll see you guys later.